I'm Aaron, and this is my MCQ progress check. So for the first one I missed, it's asking for the kinetic energy of the rod sphere system. So when you consider the kinetic energy of the rod and the sphere, so we get K equals 1/2 I omega squared plus 1/2 I omega squared, and this I will be for the rod and this will be for the sphere. First, we have to find it for the sphere, so that's mr squared. And we get the mass 0.5 times the length 0.6 squared, and we should get 0.18 as our rotational inertia. And we can factor out the omega squared divided by 2, so we get I of the rod plus I of the sphere, and you plug in this value, and if we find the omega, which is omega equals v over r, v is 2 divided by r, 0.6. Plug that in there, and plug this one in here, should end up getting 2.1 as our answer. And from part number 2, that got wrong, we're asked to indicate whether the torque on the satellite, when it will be like 0, or what it will be. So we know that it's 0, so since our satellite is in orbit, the force will always be pointed towards the object. And we know that the torque equals r cross F. So since we know that the lever arm is the perpendicular part with the force, however, since we know that the force is always pointing, that there will be no perpendicular part, so that means the lever arm is always 0. So that's how we get this one. So as for which of the following expressions is equal to the kinetic energy of the disk, so we know that it is rolling without slipping, so we get 1/2 v squared plus the rotating I omega squared. So we know that the inertia of the cylinder is 1/2 mr squared, and omega, we could just write it as omega equals v over r. So 1/2 mv squared plus 1/2 r squared times v squared r squared, and these cancel out, so we get v squared plus 1/4 v squared, and you get 3/4 v squared as your answer. And for the final one, we're asked to relate the angular momentum in the system. So that the angular momentum is mvr. So for the system 1, we have a mass of 0.04 kilograms times the velocity of 8 times the radius of 0.10, and we should end up getting 0.032. For 2, we're asked to we get mass of 0.06, velocity of 8, radius of 0.05, and we should end up getting 0.024. And for the 3, we're asked to we get mass of 0.4, velocity of 8 times radius of 0.05, and we should end up getting 0.016. And if we rank it, we should get L1 greater than L2 greater than L3, and that is the